Hello class, in this video we're going to talk about another data mining techniques, classification tree. So our example is the dynamic data. In this data set we can see, okay, for each passengers, what's their characteristics, their gender, their age, their class in a boat, whether they're first class or second or third class, which represent their social status in that time. And we also have our dependent variable, which is a 0, 1 variable indicating whether they survive the catastrophe or not. If it's 1, means they survive, otherwise they didn't. So we're trying to predict, okay, what are the people who survive the Titanic? Intuitively, we think, okay, those, for example, they are those who are in the first class, they probably be more likely to survive. And after we get this insight from this data set, then next time there's a new passenger coming on, we can predict, we can have an estimate on what's the likelihood they will survive. So with that being told, let's go to our RStudio and open this star modeling shell that I gave to you. So to do this classification tree, this statistical analysis, we need to install these packages. So what you need to do is first highlight these 4 lines and then Control R to execute these lines, and then you can call this in library into your program. Okay, this may take some time, and installing packaging will usually be very stable. So first you have to, so I skipped the step of installing package because it's already installed here, but you need to first execute this 4 line first before you call the library. Okay, now the next step is to read the data into our memory. So what you do is go to the directory where you store your data. In my case, it's this folder, and Control Shift, right click on mouse, copy as path. Now you copy the path of this file, then you can replace this with the original path I have here. Remember, you have to replace the forward dash, the backward dash to the forward dash, because that's the syntax of R in writing the directory. Okay, then you can execute this line, this first line here, read your data. Now you will see, okay, let me first clean the object first because that looks so messy, and then re-execute this line. Now I see my Titanic data. You can double click to this will give you a preview of the data. It has passenger ID, our dependent variable, whether they survive or not, what's their social class, etc. Okay, now this is our model. This is our model I'm going to use. This R part function is from the library we use there, and the dependent variable is survive, whether they survive or not. Um, and the passengers, the social class, sex, age, number of siblings, parents embark, etc. And then we're going to use the Titanic data, and the math is classification. And you will find this. So you will find that it's very difficult to type this variable name. So the trick you can use is to print the first few rows of the data by using this head function. Um, so you can get a preview of your data, just just the first few rows, and you can copy those variable name into this. Okay, and suppose we already do this. Now we can execute our model and store this result into survival tree, and then we can plot the result. The function we use to plot is this fancy R plot. So R is smart enough to give you the hint. You just press enter, so they will automatically type this function for you, and then you pass the argument survival tree here, and then put Ctrl R. Then you get the result. So let's take a very quick look at the result as we discussed in the class. So the first is in each node there is a distribution of there's a distribution of this. This is the distribution survivals. So 62% did not survive, only 38 survive. And the program tells you the first part is their sex. So if they are male, which means yes, so it says going left is always yes. So if they are male, their survival rate is only about 90%, but if they are female, their survival rate will be 87%. And as you see here, this number, which means was the percentage of so 60% of the passengers are male, and 35% are females. And among females, their survival rate is 0.74. It's a very high ratio than compared to male. And within a male group, the age actually matters a lot. So if you are very young, which means this route, no. This this going right always means no. So if you are less than 6 years old, then your survival rate is very high. You get a pretty high chance of survive. If you're However, if you're female, the age probably doesn't matter a lot. All the elderly women or the young women, they're not very different in terms of survival. Instead, the social class of female, they seems to be more important in influencing their survival rate. If your social class is larger than 2.5, which is to the left route, then survival rate is only 50%. But if you are you from the first class and you're female, then your survival rate will be 95%. That's very high. I mean, this is the insights we can get. If you are a female within the first class, you're very likely to survive. I know. So we can read this graph and get more insights. This just gives you a taste of what this data mining technique can be used and what insights we can get.